Hello everyone, Sandy Lab today is honored to introduce our new evaluation board, Pico PD Pro. This is an upgrade to our previous version, Pico PD. If you go onto our hacker.io project page, you can know more about this project, especially find all the links to the documentations. In here, if you scroll down a little bit, you can see that the name of the new chips, which is AP33772S variants. So the S character here means this is an upgrade version that will support USB-C PD 3.1. And if you go to the datasheet of the IC itself, you can see that this is an I2C sync controller. It supports USB PD 3.1 EPR, which is stand for Extended Range Power Supply. Another way to say these chips allow you to negotiate with charger that can provide higher than 20 volt. So let's say if you want to tap into 28 volt, or you want to tap into this special mode, it's called adjustable power supply. Here you can find it's called AVS. That will allow you to negotiate voltage in small increment, starting from 15 volt all the way to whatever of this board support. So in this case, it will be 30 volt. Another thing on this new evaluation board that we add on is an additional switching power supply. So it would take from your VBus, and then it would step down to 5 volt at 500 milliamp, and the LDOs would take that 5 volt and convert it down to 3.3 volt that is going to be feed through your RP2040. Very friendly microcontroller, very well known. The whole board is going to be Raspberry Pi Pico form factor, which is designed to be a drop-in replacement if you already have a project that you need a little bit more power or higher voltage. Be careful for the pin, so always scroll down and check out the pin now, because in order to have the same footprint, some pin is not directly interchangeable. If you need to read more about what is PPS, what is AVS, what is all this new term for USB Power Delivery 3.1, you can take a look at this article here. It's not really going to detail, but they cover in layman term that's pretty easy to understand, and we highly suggest you check this article out. Without keeping you guys waiting, let's take a look at the actual board itself. So here we have the Pico PD Pro hooked up to a very fancy USB-C meters. And the power here is coming from framework 180 watt. So this charger support all the way up to 36 volt, but this board is only designed to handle up to 30 volt. So that is the limit we are going to tap into today. And to enable serial debug, I highly recommend you guys pick up one of the USB-C splitter that you can also have serial communication. You can have power inject into here, and then you can power just go right through back out, and this is serial that go into your computer. All right, now let's power it up. All right, when it's boot up right here, you can see that it's only give our 5 volt, because it's a standard when you first plug anything in without any negotiations. So let's hop to VSCode and see what we can do. And when you're in VSCode, you would like to install this PlatformIO extensions. So if you go to extension and you type in PlatformIO, this is what you're going to install. And after you install, you can go back to PlatformIO and say create new projects. Here I can say Pico PD Pro demo board. You can say Pico, scroll down a little bit, you can say Pico Raspberry Pi. I'll keep in default locations, framework Arduino. And I trust the author. Now, what you would do next is you would go, now so you go back to the project page, you can click to the Pico PD Pro GitHub. Here, you just go down to VSCode PlatformIO setup. You can see that first you need to install the PlatformIO, create your new projects, and then you need to copy this here, go back into your project, and then paste it into your platform IO INE files. Now you can save it. Now I'll go back to the web. You would need to go to the library and download it, and then extract everything here, and it will place it into the library folder. So I'll go ahead and download it. Once you place it in your library folder, you should have something in this particular setup. You can say go lib, and then this file name. So let's go to example. We can go to AVS cycle, and you can copy all of these and just place in your main. Just replace your main entirely. Now you can click compile and see if it actually compiles successfully. Then you can click upload. Now it's showing that we have successfully flashed the microcontroller. Let's jump into the actual board itself, see what is it doing. So take a look at the board. You can see that the voltage is going up to 30 volt and cycle back to 15 volt. And this is, the rec power from our framework 180 watt USB-C. This can go up to 36 volt, but in this board here, we only support up to 30 volt. Let me climb it down. Oh, here I have a load resistor at 8 ohm and connect to this fixture, and I have a heatsink here just in case so it doesn't burn my table. I'll show you why. So if we go ahead and hook the board up to this PicoPD pin, you can see that it's almost 100 watt pushing through. Yeah, so you can see the board is working, and with one resistor, it would be able to pull more than 3 amp. So just in case I don't burn myself, I'm going to disconnect this. I mean, let's go back to the code, and we can explain how this code is structured. So take a look at the code here. We start with including all of our required library, Arduino, our AP33772S, and a hardware timer. Here, first we have to declare our object. Here we call it USB PD. In setup, we will set up the I2C pin according to the pin. So in this case, for Pico PD Pro and Pico PD in general, the actual chip is wiring to pin 0 and 1. Then we call begin. We're not printing anything, but I still have it here as an example anyway. And then we need to call a 1 second delay. So this delay here is to ensure the sync controller have enough time to obtain all the power profile coming from the charger. And we call begin. And then in loop, we call set output. Here you can call it beginning, or you can call it during here. Whatever you want to call it. This is when you set the output to be out or on or off. In this case, 1 mean turn the output on. If you put a 0 here, mean don't output anything. And in order to use AVS, we can quickly check it. So USB PD, and then we say get AVS index. Initially, this index could be equal to -1. If AVS index doesn't exist because there's no AVS profile, it will remain -1. And then we say when it's greater than 0, it will, return a false and skip this function. And then we call for loop. In this case here, in order to request AVS voltage, you can set AVS PDO. You have to feed in the AVS index itself, the voltage you would like it to run. Here you will start at 15 volt. And we end at 30 volt with a 1 volt increment for every loop. And then this is our current limit would be 3 amp. And some delay so we can see the effect changing on the outside. Take a look at a more interesting example. Here there's a lot of different call that we can input to the system, and there's some interaction with our serial monitor. So similar, paste it in and click upload. The chip will go back and then reboot. Here we go to serial monitor, start monitoring. Let's say if you want to display the current profile, we can press P. So with this charger here, you can see that it has fixed power profile. Starting the number of the index of that profile is 1, starting at 1, 2, 3, 4, and then there's some gap, and then it's 8, 9, 10. Okay. So you got 5 volt, 9 volt, 15 volt, 20 volt. So missing 12 volt here. Be careful, not all power supplies support 12 volt. And here from 20 volt, it skipped immediately to 28 volt and then skip to 36 volt. And then for the AVS, it print out it can support 15 volt all the way to 36 volt. But we all recommend you run up to 30 volt on this evaluation board, because that is the voltage everything is rated up to. If I want to check temperature of the system, I can press T, and here it's like, oh, it's currently 30 Celsius. And we'll hop back onto our top-down view. And if I say output on, it won't do anything because it's already on, but I can set output off. Then you can see that it go back down to 0. There's still some current because you need to fit the whole chip. But then I can say on, you can go back to the higher voltage. Let's say I would like to create a different voltage through serial monitor. So first thing first is you go back into your VSCode and you turn off your serial monitor. Right, and here I can type in else if. I already did it, so I'm just gonna paste it here for you guys. I say that I could put anything. This is just what I can type into serial. So here I would say if I type 1, do something. I would set a fixed PDO profile number 3. So here you can see profile number 3 is the 15 volt, and since we only can go up to 3 amp, so I put 3000. Now you can click upload. And the board is boot up. Now you can take a look at the hands-on, and you can see that it's still running on the old code. No, the new code is there, but the output, we haven't done anything special to it. So I can turn off the output. Right? I can turn on the output still. Now I want to reverse 15 volt. I can turn off the output, changing the voltage. Right? Then I can say O to be on, and you can see now it's 24 watt. Now I can type F to turn the output off. Now let's say I want to request something through the AVS mode. I can just copy this. Right, change this number maybe to a 2, so when I send a 2, it requests something. Here I would say set AVS PDO, and highly recommend you use this get AVS index. And if we want to do something for industrial application, let's do 24 volt and the current to be 4 amp. So if you take a look down here, you can see that our AVS voltage is valid, and our current is less than 5 amp is also valid. So now make sure you don't have serial monitoring turned on. Right, it's not on. Now I can click upload. Now take a look at the chips, and then let's turn our serial debug on. Now let's test regular P. Still work. Right, on, off, still work. Let's say everyone AVS, I will type in 2. You see the voltage go to 23.99, which is close to 24. And now I can say on, and you can see the power is now 61 watt. Right, and it's off. Happy hacking, everyone.